Alright, so I'm going to move on to the next question, which was about electric fields and break down similar sort of things to that involving capacitors. So, first thing is we're charging the electrostatic generator at a constant rate of 3.2 times 10 to the minus 8 amps. Breakdown field strength is 2.5 times 10 to the 6 volts per meter. Capacitance 3.7 times 10 to the minus 12 farads. So, what we need to do is calculate the minimum PD for a spark to occur, which means the electric field has broken down. So, what we need to do is calculate the breakdown field strength and rearrange that. So the breakdown field strength would be calculated like this. We know what the breakdown field strength is, we know what D is, so the potential at which it breaks down would be like this. So it's going to be 2.5 times 10 to the 6 times by 12 times 10 to the minus 3. Let's cancel those off straight away. And if you multiply those out, you end up with 3 times 10 to the power of 4. Obviously giving it the right number of significant figures there. Okay. So then it's asking you to calculate the time taken from when it's switched on for the potential difference across the disk to reach the value. So, first thing first, we need to calculate the amount of charge that it's going to take to get that potential. So that's using this equation. So then let's put in our capacitance. And our potential difference. And that gives you 1.11 times 10 minus 7 coulombs. Now it's charged at a steady rate, so we're going to rearrange Q equals IT, and T is going to be Q over I. So we've got the amount of charge, we've got the current that it's being charged at, is given to you in the question, and if you plug those numbers in, let's cancel that straight away, and then plug those numbers in, you end up with 3.5 seconds. That's the time it takes from not being charged at all to acquire the charge you need. So to get the charge, we took the potential difference and the capacitance to get the charge, and then Q equals IT because it's told you it's charging at a constant rate to answer the next one. So let's move down. So if we replace the disks with ones with a larger area, so they have a larger capacitance, we need to think about what will happen to the time between discharges. So it discharges every time it reaches the breakdown potential. So if it's a larger capacitor, it takes more charge to reach the same potential. So actually, if you increase the capacitance, it takes more charge to get to the breakdown potential, and if you're charging it with the same current, actually it's going to take longer to there, so the time between discharge will increase. So that's the first thing, so stating, actually your time increases. Why? Well, so to get to the same potential when you've increased capacitance, therefore you need to increase the amount of charge. And then thinking about it, Q divided by I, if you've increased the number of the charge while this stays the same, then you're going to increase the time taken to build up to the breakdown potential, so you increase the time it takes to get a discharge. However, if you increase the capacitance, whereas the breakdown potential is the same, so this is the same, this is increased, the energy stored in it will increase. So if you have more energy being discharged, you're going to see that in terms of the brightness increasing because of the increase in energy stored due to the increased capacitance.